In this section, we're going to be talking about combinations of functions, such as composite functions. We're going to add, subtract, multiply, divide functions together. We're going to find compositions of functions. That is, we're going to combine them and see how one goes into the other, or one adds or takes away even from another. And we're going to do that with a real-life example at the very end. The first thing we're going to be talking about is the arithmetic of functions. That is, let's say that f of x is equal to 2x minus 3. That is, g of x being x squared minus 1, and you're asked to simply add those two functions together. So the first one we run into is the sum of two functions, f of x plus g of x. If you want to try these out, if you think you might be able to solve these ahead of me, go ahead and pause the video. If not, let's take a look at what f of x plus g of x looks like. Because I'm just asked to add these two together, I'm going to take f of x and I'm going to add f of x to g of x and simplify the result. In addition, I don't have to worry too much about really anything. Parentheses plus parentheses, really don't need those there, just putting them right now just so we can just separate the two functions, but really you combine like terms and we find out that in adding those two we get x squared plus 2x minus 4. Now we look through these numbers, x squared nothing to add to, 2x nothing to add to, but then the only ones that really combine are the negative 3 and negative 1. Negative 3 plus negative 1, negative 4, or minus 4. So our final answer, we started with two functions involving x, added them together. We still have a function, or the result still involves x. We don't have numbers, so we should not get numbers back, we get expressions back. Likewise, difference. This one, small catch, because we are talking difference of two functions. When we go to subtract, we just have to be careful. Same setup as before. 2x minus 3. This time, though, it's minus x squared minus 1. My suggestion to you is here, because of that minus, you might want to rewrite this equation first. So 2x minus 3, nothing going on. Just leave it alone. Don't need the parentheses. Drop it. Minus the x squared minus 1. It's easy to say minus x squared and then be done. And then you forget the fact that the minus is the entire function. And minus needs to be distributed to both of those. So that becomes minus x squared, and minus negative 1 becomes plus 1. That's the slight difference. Still combine like terms, x squared, nothing to combine it with, 2x, nothing to combine it with, but this time it's minus 3 and plus 1. The x squared also was a little different. It ended up being negative x squared plus 2x, and minus 3 plus 1 is minus 2. So notice a slight difference there. On this next one, the product, this is probably the one that's the most involved, because I'm asked to multiply two functions together, and both of those are expressions. It's going to lead to a little bit of work, because when I say 2x minus 3 times x squared minus 1, unfortunately what that means is that I have to, if you remember this from algebra, FOIL. That is 2x, and let's bring that down here to see the work in between. So 2x minus 3 times x squared minus 1. When I FOIL, I get 2x times x squared, so 2x cubed. Then I'm going to get 2x times negative 1, which is minus 2x. Then negative 3 times x squared, negative 3x squared. And then negative 3 times negative 1 is plus 3. Could have skipped that step, because when I look closely, I find out that, well, there's really nothing that combines. No like terms when I'm done. But there's going to be a slight difference from the foiling of those two to the answer you're about to see. And that is, it must be put in order of descending powers of x. So notice there's just the middle terms just got swapped around. no big deal. It's not a bad idea to do the FOIL separately, just in case you do have a little cleanup to do. Either way, it was not necessary as long as you knew in the end the negative 3x squared goes before the negative 2x. All right? The quotient is probably the easiest one because most of the time there's not much work to do with the quotient. F of x divided by g of x simply is those two things divided together. That's it. Now, there is one extra step you must do just in case for this is to say, well, 2x minus 3 over, and then x squared minus 1. Well, x squared minus 1, if you remember, that's a difference of squares. That's really x plus 1 divided by, or times x minus 1. So all of those, so all of that, 2x minus 3 is being divided by both of those things. If anything cancels from top to bottom, then at this point you would step in and say, okay, let me go ahead and cancel that. But most of the time that won't be the case. When it is, of course, you're going to go through and find a quotient, cancel what you can. But there's also a reason why we want to go ahead and factor anything, especially the denominator. Because in the division of anything that involving x, we always want to consider and take into account the fact that, hey, x could be equal to 0 on the bottom of, or the whole bottom of this fraction could be equal to 0. And if it does, I cannot divide by 0. So I have to look at these problems and say, okay, what are my restrictions here for division? In that case, x plus 1 cannot equal to 0, which means that x cannot equal to negative 1. Likewise, x minus 1 cannot equal to 0, which means that x cannot equal to 1. So I have some restrictive values here, but that's the only thing that's different with division. Just I have some restrictions. If you cancel, great. Most of the time, you run into just problems that probably not going to do too much with. But always look out for factoring and the possibility of canceling values. But even if something cancels, you still have restrictions that where the denominator of your fraction cannot be equal to 0. Take a look at this example where f of x is equal to 2x plus 1, g of x is equal to x squared plus 2x minus 1. They're asking you to find f plus g of x. Then evaluate the sum when x is equal to 3. So we have a couple of approaches here. We're going to take a look. The sum of f and g is just like we did before. We take f of x plus g of x. So if you want to try this out, go ahead and pause. If not, let's take a look. So f of x plus g of x is 2x plus 1 plus the whole quadratic expression of x squared. Combine like terms, we end up with, oh, interesting. So plus 1 minus 1 kind of took care of itself. That looks a lot simpler than what it started off with, which sometimes is nice when that happens. So combine like terms, 2x and 2x, that's 4, plus 1 minus 1 cancels. So f plus g of x is really x squared plus 4x, right? Then it says, okay, let's evaluate that sum when x is equal to 3. So this time I'm going to say, okay, what's f of g of 3? Or f plus g of 3? So f plus g of 3 means that in that equation, I can say 3 squared plus 4 times 3. And so that's 9 plus 12, 21. And if you want some separate values for that, sure, why not? 9 plus 12. But wait a minute, do you really have to add those two together first and then evaluate? Well, notice what they said here. F plus g of x is equal to f of x plus g of x, right? So why not do f of 3 plus g of 3? Let's see if that works. That is, right here, I can say, okay, 2 times 3 plus 1 plus 3 squared, probably best to use parentheses there, plus 2 times 3 minus 1. let's just, for fun, why not? Let's just go ahead and add those, or evaluate at 3 first, and then add all those results together. So let's see what kind of numbers we get. So next, and I'm kind of working unconventionally up the chart at this point, 2 times 3 plus 1 is 7. 3 squared is 9 plus 6, that's 15, minus 1 is 14. So it's 7 plus 14. Well, 7 plus 14 is 21. So I could have done that first. But if they ask you to find f plus g, then you actually want to give them this answer here. Well, can we just plug in the 3 here? Let's see. 3 squared. Oh, wait a minute. We already did that. So that's the other method where, okay, well, I can add them together first as expressions and evaluate second, or I can just plug in the 3. It just depends on the situation, where you might have to do one first for the other. But notice that when we put in a number such as 3, we got a solid number back. But when we just said x, we got an expression in return. Composition of a function. F of x is x squared, g of x is x plus 1. The composition of f of x with g of x is, it's different than multiplication. Notice how this time, instead of f of x is now f of g of x. That means that g of x replaces x in f of x. That means everything that g of x is equal to is now going to go into the f of x equation where you see an x value. So that is f of x plus 1. Because remember that g of x was x plus 1. So because g of x is x plus 1, every time you see an x value inside of the f of x equation, which was x squared, that is now going to be x plus 1 squared. So here we have f of x being replaced with a whole entire equation this time. That equation is x plus 1, or expression is x plus 1. So x plus 1 expression goes into the f of x expression. So it's like you're taking not just a number, but you're replacing an entire expression into another. That's called the composition of a function. Now, as we know, x plus 1 parentheses squared, we have to deal with this carefully, because this is going to be equal to x plus 1 times x plus 1. We will FOIL, a shortcut to foiling squares, perfect squares in this case, the x, or binomial squares. X plus 1 to the second power becomes x plus 1 times x plus 1. You square the first, so square x. You square the last, 1 times 1. You multiply the two things together, so 1 times x, and double the result. So f of g of x, when you take x plus 1 into x squared, you get x squared plus 2x plus 1. All right? Composition of functions simply says that you're taking an entire equation or expression, taking an entire expression that plugs into another. Likewise, we can do that backwards, except that the result a lot of times ends up being different. Just keep in mind, when you see something like h of x, remember f of x, g of x, h of x, q of x, doesn't matter what it is, it's just a way to keep them as separate expressions or equations. Functions, still function notation, just not saying f of x every time. So h of x being equal to 3x minus 5 quantity to the third power, really it looks like the composition of x cubed in 3x minus 5. That is, the outer function x cubed got it substituted with 3x minus 5. So now 3x minus 5 goes into the equation. That is, well, 3x minus 5 is what we saw inside of h of x. That is, well, it's the same thing as g of x. So that's the same thing as g of x cubed. Well, x cubed was f of x. So it's like they took all of this and plugged it into this. We can split those as, the inside function, the outside function, whatever it is, based on those compositions. Bottom line is, when you create a composition of a function like this one, you notice that 3x minus 5, all of that goes into the x cubed, which means that the problem gets a little more involved. How do we simplify this expression? So we're looking at, okay, so we did f of g of x where we put something into cubed. Was pretty simple, now it's not going to be. But keep in mind that 3x minus 5 to the third power is 3x minus 5 times 3x minus 5 times 3x minus 5. How do we solve or simplify an expression like this? We take 3x minus 5 and FOIL to 3x minus 5. And then we get to the last one, it's like, well, not really going to FOIL. There's not really a way to FOIL at that point, but we are distributing. We are multiplying these expressions together. So if we use the shortcut, we can do 2 right off the bat, and that is 3x minus 5 squared is like saying 9x squared. So we square the first. Negative 5, we square the last. And then we multiply the two together. 3x times minus 5 is minus negative 15x, and then double the result, negative 30x. That's just a shortcut to foiling. You can expand it, just go ahead and FOIL it out and then combine like terms, but this will save us a step. Now keep in mind too, I have not done anything with this last guy here yet. Can I just select that one? No. So we still have this one right here, 3x minus 5. Have not operated with this last one. Just changing colors a little bit to show you that this guy is just going to move down. I've only taken care of the first two. But then I got to multiply those two together, and it's a longer expression, and now, well, I really don't have like a FOIL method for this, but you are literally just distributing. You're multiplying the 9x squared to the 3x, 9x squared to the minus 5, and then you're going to go, okay, this one in the middle to both, and the last one to both. Then if you're doing FOIL and you're like writing the lines, it gets messy, and so it gets everywhere. So for those of you that appreciate biology, and for me, like when it came to biology, the only thing I really liked about biology was this next thing I'm about to do, because that was truly like the only mathematical portion of it. When we dealt with kind of like a Punnett square, when we did like genotype, phenotype, and calculating probabilities and chances of something happening. But what it is just a way to organize, even for these expressions. So I'm multiplying these two things together. You take the first one, 9x squared minus 30x, and then plus 25. And you can emphasize pluses and minuses just for a good measure. I'm going to multiply this with 3x and then minus 5. Like I said, almost like a Punnett square. It's just an easy way to organize this information here. You don't have to do it this way. If you just want to distribute, you can. So then 3x times 9x squared. We multiply those two together. We end up with 27x cubed. Notice red and blue makes purple. There's your art lesson again. Then 3x, negative 30x is negative 90x squared. 3x and 25 makes plus 75x. So now all of those have been multiplied by 3x. Now let's go with negative 5. Negative 9, negative, or positive 9x squared. Negative 5 is negative 45x squared. Negative 5 and negative 30 makes plus 150, and then x. And then negative and positive makes negative 125. Really cool thing about this is that when it's time to combine like terms, you almost just have to look diagonally here. Let's actually change colors on that. Just look diagonally for the things that combine. And so here our final answer is going to be equal to 27x cubed. And now I have minus 45 minus 90 minus 135 x squared. 150 and 75 makes 225 x, and then minus 125. All right. Again, it organizes the results of those multiplications for you. And you also see, like terms you can't combine. But bottom line is, we had to multiply this 3 times. 3 different expressions multiplied together. It gets to be a little more involved than just, a FOIL process. So now let's put it all together, and I want you guys to give this a shot. So this is definitely a time I want you to pause and see if you can solve and simplify and find the following 3 results. Notice now, this might look a little different, but if you've done composition of functions before, note that f and then this little O looking like dot, it's not multiplication, and then g of x, we often call that fog because we're talking about f of g of x. Those 2 things are exactly the same. That is composition of f of x and g of x. But again, the inner function is g. So x goes into g, no substitution there, so really not a necessary step. But then g of x goes into f of x. Work from the inside out. Likewise here, x goes into the f equation, meaning no change. F of x, then the result goes into g of x. The reason why I did those 2 is because on the last one, oh look, -2 goes into the f equation. That will give you a number instead. And then f of x, the result of f of -2, the result then goes into the g equation. So you're always working from the inside out with those. If you're starting with x, you really don't have to do that inner step because, well, it's just going to give you that expression. So again, like I said, at this time, I do want you to pause. I want you to take a look at each one of those and see what you come up with. But right now, I'm going to show you what happens when we find f of g of x for part A. So fog, you're going to take g of x, and g of x is 4 minus x squared. This is going to be f of, in place of g of x, 4 minus x squared. So every time I see an x, I'm going to replace that with 4 minus x squared. So in this case, x was that portion of my equation. X has been replaced with 4 minus x squared. The plus 2 is untouched. Then I simplify. In this case, 4 minus x squared, nothing really to do. Highest power first. And then, so that brings the negative x squared to the front. 4 plus 2 is plus 6. So for this one, f of g of x results in x squared plus 6. Remember, I started with x. I'm going to end up with x. For the second one, g of f of x, and that doesn't have a fancy name like fog, we'll just call it golf if you want, especially if you're a Rams fan. But in this case, we're looking at f of x going into g of x. So everything that is, let's reverse the colors because that's what we had. So this time I'm going to have g of, and so this was part B, this is part A. Just keeping it color coded for you because I'm going to run out of space really fast. So g of f of x, that is, f of x is replacing x in the g equation. That is, f of x, which is x plus 2, is going to go into 4 minus, be very careful here, I'm only replacing the x. I'm replacing the x with x plus 2. Notice I did not replace the minus, I did not replace the square. This one requires a little bit of work because I have a parentheses squared. So this becomes 4 minus, and then x plus 2 times x plus 2. The minus cannot be ignored either. 4 minus, and if you want to do the quick FOIL for this, that's x squared. X times 2 is 2x, and then double the result, so 4x. And then square the last, which is 4. You can also just FOIL it out if you would like. Then I have to distribute the negative, so 4 minus x squared minus 4x and minus 4. It's really easy to lose track of that negative, or just say, oh, it's minus x squared, and then just leave the other ones alone. The minus has to distribute. So clean up by writing the highest power first. X squared, combine like terms if we have any. Minus 4x can't do much with. And then 4 minus 4, oh, those two will cancel. So our final answer for g of f of x, or g of x plus 2, ends up being negative x squared minus 4x. One last one. Let's make this one purple. This time they want g of f of negative 2. So, well, it says, okay, plug in a negative 2 into, this is part C. So if I plug in a negative 2, find f of negative 2 first. Well, f of x was x plus 2, so I'm replacing x and only the x with a negative 2. Let's change some colors here, because this is f of x. So let's say I'm replacing with a negative 2, and this was again part C. Well, negative 2 plus 2 is 0. So f of negative 2 is really equal to 0. Then that result goes into the g equation. That is, now I'm going to say g of f of x but we just found out that, well, f of x was, when I use a negative 2, I get a 0. That means I'm really looking for g of 0. Which is equal to, well, 0 is going to go into 4 minus x squared, so 4 minus 0 squared. Well, 4 minus 0 is 4. And you're probably thinking, you just did a lot of work. And you're right. Didn't we already find out what f of, or g of f was equal to? We did. So we could have gone, instead of doing all of this where I plug in a 4 here, why not just go over here and plug in that negative 2? Let's try that. So the other option for this is finding out, okay, so let me go ahead, because I already know what g of f of x looks like, let me plug in a negative 2 here. So let's find out what g of f of negative 2 looks like if I already know what g of f of x looks like. That is negative x squared minus 4x. So I plug in a negative 2. Negative 2 squared is 4. Make it negative. Negative 4 times negative 2 is 8. Positive. What's negative 4 plus 8? Same answer. But honestly, that takes a lot more. But since we had already done that, we could have used it. I would suggest using what we did here in the beginning of part C, where we said, okay, let's find negative 2 evaluated at the f equation, then take that result into the g equation. That's probably a lot easier, but since we kind of already did the hard work for finding g of f of x, you can also use the result of part B to find part C. Completely up to you. Just keep in mind that sometimes we might have a shortcut. All right?